In this video, we will discuss and solve this fun geometry puzzle. So we have a quarter circle here, and there's a weirdly inscribed right angle. This is 24 units, and this is 7 units long. The goal is to calculate the area of the blue region. Do you think you can do it? Then go ahead and hit the pause button. The first step is to label the vertices as A, B, D, and E. Then extend the quarter circle arc to form the semicircle as shown. Label this point as C. Recall that a right triangle is formed when one side of the inscribed triangle is the diameter of the circle. This is a right angle. So if we extend line DE, it would coincide with point C forming the right triangle ADC. Next step is to draw the line segment AE. This segment is also the hypotenuse of the right triangle ADE. Let's find the length using the Pythagorean theorem. AE squared is equal to 24 squared plus 7 squared. 24 squared is 576, and 7 squared is 49. 576 plus 49 is equal to 625. Take the square root of both sides. We get AE equals 25. If we assume R to be the radius of the circle, then both segments, AB and BC, are equal to R. This makes line AB congruent to line BC. Moreover, do not forget that these angles are 90 degrees. Now, it is apparent that this radius is the perpendicular bisector of the diameter AC. As this radius bisects the diameter AC into two congruent parts at right angles. Recall that the perpendicular bisector is equidistant from the endpoints of the line segment that was bisected. Therefore, CE is equal to 25. The next step is to solve for the radius R. Using segment addition, the length of diameter AC is R plus R, or simply 2R. Meanwhile, the length of segment CD is 7 plus 25, which is 32. Time to solve for the radius R using the Pythagorean theorem equation again. 2R all squared is equal to 32 squared plus 24 squared. 2R all squared is 4R squared. 32 squared is 1,024, and the 24 squared is 576. Adding 1,024 and 576 together gives us 1,600. Divide both sides by 4 to get R squared equals 400. Take the root of both sides, and we have the radius is equal to 20 units. Let's revert back to our original figure. We already solved the length AE from earlier, which is 25 units. This segment divides the shaded region into two right triangles, triangle ADE and triangle ABE. But before we could solve for the area, let's find the length BE first using the Pythagorean theorem. BE squared plus 20 squared is equal to 25 squared. 20 squared is 400, while 25 squared is 625. Transpose 400 to the right side and make it negative. BE squared is equal to 625 minus 400, or 225. Take the root of both sides, and we have BE equals 15. Recall that the formula for the area of a right triangle is 1/2 times base times height. Now we can solve for the area. The area of triangle ABE is 1/2 times 20 times 15. 20 times 15 is 300, and half of 300 is 150. Now, the area of triangle ADE is 1/2 times 7 times 24. 7 times 24 is 168, and half of 168 is 84. Finally, the total area of the shaded region is just the sum of the areas of the right triangles we have calculated. That is 150 plus 84. So the area is 234 square units. Thanks for watching.